Hello everyone, I am Mitikaa Sama and we are group 29. We will be presenting the demo for a language DMNS. Coming to the presentation overview, we will be talking about the languages that influenced our language, the key features that we've provided in our language, the grammar, lexical analysis and parsing tools we've used. We'll give a short overview of our runtime. We'll conclude by discussing a sample program and giving a project demo. So discussing the languages that influenced DMNS, it is similar to what Python and C do. Our language uses block structures indicated by curly parentheses, that is similar to what C does. And our language also supports dynamic type checking, that is similar to Python. DMNS is easy to read and easy to learn. These are the key features that our language provides. We've supported integer and Boolean data types and a few relational operators. We've provided modularity with the help of functions. We also support conditional statements and loops. The user has an option to use an inbuilt data structure, that is tag, and we've implemented the language supports recursion and lets the user also use print statements. This is an example of how our grammar looks like. For example, it starts with a program and then it divides into multiple lines. A line can be an assignment statement, it can be an if condition, it can be a while loop, etc. It can also be a function. For example, in this, a function can have a function declaration and a function body. The function declaration has the keyword func, it starts with, followed by a function name. Now the list of parameters is optional. You can have 0 or multiple parameters. The function body can again have multiple lines followed by a return statement. This is it for the grammar part. Now we will continue to the lexical analysis and parsing, which will be taken over by Soham.
Thanks, Mitikaa. We are using a tool called Antler, which stands for another tool for language recognition for our lexical analysis, parsing, and translation phase. Antler makes it easy to do the above mentioned tasks and has a very intuitive process for achieving translation. The first step is to read the high-level program and generate tokens. Once the tokens are generated, it is passed on to the parser stage of Antler, and we can see the parsed output on the next slide. So on this slide, we can see an example of Antler in action. The parsed information is used to obtain the intermediate code using the listener interface provided by Antler. Antler has a built-in tree walker, and the listener interface responds to events which are triggered by the walker. Every time the tree walker encounters a rule, like for example line in our case, it will trigger a method such as enter line and visit all the children nodes. Once it has visited all the children nodes, such as assignment, it will trigger exit line. So in our example, we have the line a equal to 5, which translates into move space a space 5. The way this works is, first the line production is entered with enter line, then the enter assignment method is triggered. This is where the identifier and the value associated with it is determined. After this step, the exit assignment rule is triggered, where the move statement is associated with the identifier and the value. So this is just a simple example of line translation. So now Nitesh will explain the runtime environment.
So we have implemented our runtime in Python. So runtime takes assembly file generated in previous tab as a command line argument and it interprets it line by line. And so the main thing for any language to work correctly is the scoping and maintaining the symbol table as it enters and exits each of the scope. So we have maintained our symbol table for the language using the stack of dictionaries. So whenever it enters a new scope, we just push a new dictionary on the top of the stack and we maintain all the variables for that scope itself in that dictionary. So whenever the execution control exits the scope, we just pop out that dictionary from the top of the stack. So our function has a two level of scoping. So one is a global scope, another one is a function scope. So, and we also have a block structures which supports like if else statement as well as a while statement. So if you declare any variable inside these structures, it won't be accessible to you outside these block structures. Our language supports two data types, integer and Boolean. So if we perform any arithmetic operation on an integer and a boolean, our runtime will throw an type mismatch error. Now let's have a look at sample program. Here we have written a program in DMNS, and the extension of the file is HL. The program does the summation of numbers from 0 to 10. When we compile this, we get the assembly code as shown here. The extension of the assembly code which is generated here is .am. Uh, and next we pass this assembly code to our runtime environment, and the runtime executes this assembly code line by line, generating the output as shown here. Next, Deepti will take over and run through some of the examples which we have written in DMNS.
We'll go to the sample program now. The high-level language has an extension of .hl and the intermediate code has an extension of .am. We will generate the intermediate code using Java and execute the code using Python. This is a sample program to compute the nth term. This is Fibonacci series. Let me explain what exactly the program does. The input actually that is being passed is 7, and we are recursively calling the function till we reach the exit condition. This is actually the high level code. Now let us compile it. Okay, so now we have compiled the code, and let me walk through the intermediate code for Fibonacci series, and this is how it looks like. And now let's go and execute it. The output of the Fibonacci series is 13. Let's look at the next program, stack implementation. We have 3 functions in here: push, pop, and empty. We are declaring the stack, and we are pushing the elements 1 through 5 one by one, and we are popping the elements until the stack is empty. And now let's go and compile the program. The program has compiled successfully, and now let's go and have a look at the intermediate code that has been generated so far. And let us go and execute the intermediate code now. If you see, the elements are displayed in the reverse order in which it is pushed. Our next example is on the scope. Let us have a look at the high-level language that we have written. We have declared the variable n as 5 in the global scope, and in the function we have created a local variable, and we are initializing it to value 10. Now let's go and compile this program. The program is compiled successfully, and now let's go and execute it. As you can see, the scope of the variables are displayed correctly, the function with the value 10 and the outer with value 5. Now let's look at an example of compile time error and runtime error. So this is the program that we have, functions.highlevel language, and if you see over here, the function 2 doesn't return any value. So let's go and execute it. Let's go and compile it. So if you see over here, it's actually expecting a return statement, so it's giving an error. Now let's look at an example of runtime error. So we have the program while.hl. If you see over here, we are initializing the value sum to be an integer, and the val is a boolean value, and in the loop we are trying to add an integer value and a boolean value. So let's see what happens. The expected output is that the program will compile successfully, but then since it's a runtime error, our runtime will catch it successfully and it will display the error. So let's go ahead and compile it first. So it is a successful compilation, and now let's go and execute it. As you see over here, it says type mismatch while performing arithmetic operation. Please refer to instruction manual and installation guide for more details, and thank you.